Today we're going to cover section 4 of chapter 9. We're going to start our trigonometry. So today we're only going to be talking about the tangent ratio. Now, trigonometry, the definition is the study of triangles, more specifically right triangles. We're going to be covering 3 different trigonometric ratios. We're going to be covering the tangent ratio, and that's what we're going to talk about today. We're also going to be covering the sine and the cosine ratios. Now, the trigonometric ratio is just a ratio of the lengths of 2 sides of the triangle. The tangent ratio specifically is going to be the side that's opposite over the side that's adjacent. And they're going to tell you which angle they want you to state the ratio for. Now, this can also be used in addition to finding missing sides. We can also use it to find the measure of the acute angles of the triangle. When we start out our problem, you're going to be given 2 pieces of given information. They're either going to give you 2 side lengths or possibly an angle measure and a side length. Once we learn how to set up the ratio and use these ratios in our calculator, we will be able to complete the triangle. And when the instructions say complete the triangle, it means it wants you to find all 3 angle measures of the triangle and all 3 side lengths. So let's go ahead and take a look at the tangent ratio. And it must be a right triangle. So here it says let triangle ABC be a right triangle, and it's going to talk about, in this particular slide, acute angle A. So when you want to write the tangent of angle A, it's going to be defined as follows. You would have the word TAN, then the angle measure they want you to find, and then you're going to set up a ratio. You're going to find the length of the leg opposite to angle A over the length of the leg adjacent to angle A. So what you're going to do is whatever angle they tell you, and in this case it's angle A, I'm now going to label my sides. I'm going to put in and give each side the name either hypotenuse, opposite, or adjacent. The first thing you should always label is the hypotenuse. And remember, the hypotenuse is always the side that's opposite the right angle. So C is my hypotenuse. Now, still only talking about angle A, the side that is opposite to angle A is going to be this little a that's over here. So this is the opposite side to angle A. And then the side that is adjacent or next to angle A that doesn't have the name hypotenuse is this one, side B. So once you get your triangle, you should put these 3 names on the 3 sides of the triangle. Again, the hypotenuse will always be across from the right angle. And then whatever angle they're asking you to find the ratio for, that's where you're going to put in the label of opposite and adjacent. Now also, when you're labeling your triangle, notice the angle measures all have capital letters. The sides directly across from them or opposite them are the lowercase letter of that angle. So angle A, then the side opposite to it is lowercase a. When you have angle B, the side opposite to that will be lowercase b. And then for the C, angle C, opposite to that will be lowercase c. So when I want to write the tangent ratio for angle A, I'm finding whatever side was opposite, and I'm going to put the side that's adjacent to A in the bottom. So the side that was opposite to angle A was lowercase a, and the side that was adjacent was lowercase b. And that's what was written here. Now, we will never find the tangent ratio for the right angle. Let's say instead they wanted us to find the tangent of angle B. Now that I've changed the angle, I need to change the labels on my sides as well. So now that they want me to reference angle B, I'm still going to put in the label of the hypotenuse over here on C. But now that I'm talking about angle B instead, the side opposite to angle B is now little b. Notice in the other triangle, the little b was the adjacent when I was talking about angle A. But now opposite to angle B is little b, and adjacent to angle B is little a. So now when I put it into the ratio, I'm doing opposite over adjacent, so I do B over A this time. Let's try it with some numbers. So the next slide wants us to express the tangent of R as a ratio. When they want us to just express it as a ratio, I'm not using my calculator. I'm just putting opposite over adjacent. So let's label the sides in relation to where angle R is. So angle R is over here. So in relation to angle R, again, here's my right angle. So this one's my hypotenuse. And then opposite to angle R is the 3. And next to or adjacent to angle R is the 8. So when I want to express this as a ratio, I'm doing opposite over adjacent. So my answer is 3 over 8. When it wants me to find the tangent of angle S, the other acute angle, now I got to change my names. So now, in relation to S, the side that's opposite to S is now the 8. And the side that's adjacent to S is now the 3. So when I want to do the tangent of S, now my fraction flips. I'm still doing opposite over adjacent, but the names for the sides changed because the angle changed. The question just asks you to express it as a ratio. You just put it in a fraction. Now, let's say on that first one, let's say it was 4 over 8, you would have to simplify it to 1/2. So if your fraction can be reduced, reduce it. Now, you might also see, and if they don't have variables on the angles, sometimes what they use to represent an angle is this Greek letter. This is a Greek letter of the alphabet. This is called theta. And it's just used to hold the place. Instead of putting angle R here, they might say find the tangent of theta. And again, it's still just opposite over adjacent. So if there's no letters on the picture, sometimes they'll just put this generic symbol in there, and that symbol just represents the angle. So let's try the next example. Now we're going to practice with our calculator. So we already did tangent of 45 on our calculators. Everybody should have gotten 1. Now everybody, I want you to try to do the tangent of 36. We're going to round to 4 decimal places. You should be getting 0.7265. If you're not getting that, let me know and I will help you. So just read the directions. In the homework, I believe they're making you round everything to the tenths place. So just read. The question will specify how many numbers to round to. Yeah. On A and B here, was it 1 and 2? On A and B here, they gave us the angle measure. For part C and D, we don't have the angle measure. We have the answer. So what we're going to do is use the inverse tan function. So on your calculators, you're going to hit the shift button. Some calculators have a shift button. Other calculators, it's the second button. And then you're going to hit the tan button. And then it should open up tangent -1. Then you're going to put in the answer, 2.4751. hit enter. We're going to round to the nearest tenth. So you're going to get 68.000. So we're going to round it to 68.0. This would be the degree measure for that answer. Now, some calculators, you have to hit the 2.4751 first, then hit the shift and the tan. Every calculator is different. Some calculators, you have to hit the tan button twice and then put in the angle. It should be opening up something on your calculator that shows tangent to the -1. Do the next one as well. You should be opening up tangent to the -1, the inverse tangent, put in the 0.8098, hit enter, and this should be giving you 39.000 something, rounded to the tenths place, 39.0. Now, not all of the answers are always going to be 0.000. They are going to have other numbers when you go to do the homework. Okay, so now, notice the instructions at the top. It says using tan to complete a triangle. Now, when you get a question like this on the test, it's not going to give you step by step of what you need to fill in. Whenever you see the instructions that say complete the triangle, what they want us to do is find all three angle measures and all three side lengths. So by the time I'm done, I should know that the measurement of angle A, the measurement of angle B, the measurement of angle C, which I have from the beginning, it's 90. I will also know the length of BC, which was given to me, it's 2. The length of AC, which is 7. And then I can also find the length of AB. So when I'm done, I'll have all 6 numbers. Now, the first thing I'm going to find is the length of AB. Because this is what we learned in 9.1. We used the Pythagorean theorem. So in order to find this hypotenuse, I'm going to do a squared plus b squared equals c squared. Now, the side across from A is little a, the across from B is little b, and my hypotenuse is little c. So let's fill in my numbers. 2 squared plus 7 squared equals c squared. 4 plus 49 equals c squared. 53 square root, and c is equal to the square root of 53. That is the length of AB. Now, if it said exact or simplest radical form, you would leave it like that. If it said to round the side length to the tenths place, then you would use your calculator. Just make sure that you just read the instructions. So we can either leave it like that. If it said to the tenths place, I would do the square root and get 7.3. So just read. Now, so far now I found the 3 sides. I now need to go back and find the 2 acute angles. And in order to do that, I'm going to be using my inverse tangent. So what I'm going to do here is first find tangent A. So let me label my sides based off of angle A. So angle A is here. So the side that is opposite to angle A is the 2, and the side that's adjacent is the 7. So the tangent of A, the ratio, is 2/7. I'm going to use this ratio to find the answer to part C. So to find the measure of angle A, I'm going to do inverse tangent, and then I'm going to take and put the 2/7 here. Now, if your calculator does not let you input things as a fraction, we're just going to use division, because that fraction bar means division. So we're doing 2 divided by 7. You need to enter the 2 divided by 7 in parentheses. Once you hit enter or the equal sign, you're going to round to the tenths place, and this is 15.9 degrees for the measure of angle A. So I use the tangent ratio. Now, I'm going to go back and do the same thing. I'm going to relabel my picture and label the sides based off of angle B now. And I'll go ahead and label those in pink. So now, for the tangent of B, here's angle B. And the side that is opposite to B is now over here. And it's the 7. And then the side adjacent to B is the 2. So when I go to put it into the ratio, opposite over adjacent, it's 7 over 2 now. And again, to find the measure of angle B, I'm doing the inverse tangent function, 7 divided by 2, or enter it as a fraction. Once you hit enter, rounded to the 10th place, 74.1 degrees. So now that I've found the two acute angles, I have now completed my triangle. So angle A was 15.9 degrees, angle B was 74.1. Now, also realize that A and B together, they're complements. If you were confident with this answer, to find B, you could have just done 90 minus 15.9 and got 74.1. Know that these two added together need to add up to be 90. If they don't, you've done something wrong. Also realize that these are acute angles. If you get something bigger than 90 for those two, that's another clue that you've done something wrong. Said instead, round to the nearest degree, then this would be 16 degrees and this would be 74. So just read how they want you to leave the answers. The big idea is once to the 10th place. Now the next question is exactly the same thing, but they don't give you the lines to fill in. It just says complete the triangle. So I'm doing exactly the same thing. I need to find the measurement of angle A, angle B, angle C, side length BC, which is 8, side length AB I have is 17, and then AC, which I don't know. The C was the 90 degrees. So again, if you have two of the sides, all you're going to do is Pythagorean theorem to find the missing side first. This is actually a Pythagorean triple. So if you've memorized those triples, you don't need to do this, but I'm going to go ahead and label everything. So across from angle A is lowercase a, this is B, and this is C. So 8 squared plus B squared equals 17 squared. 64 plus B squared equals 289. Subtract 64, and B squared equals 225. Square root, and B equals 15. It's a triple. So now the length of AC is 15. Now I need to go back and do the inverse tangent ratios to find angle A and angle B. So let's first do angle A. So here's angle A. The sides in relation to A, 17 is the hypotenuse. Opposite to angle A is the 8, and adjacent to angle A is the 15. So I'm going to be doing tangent of A. This is what I'm using, and I'm doing opposite over adjacent. So now to find the measure of angle A, I'm using the inverse, and I'm doing 8 divided by 15. Or enter it as a fraction if your calculator lets you. Once I hit enter, rounded to the 10th place, 28.1 degrees. Yes? What is the inverse? For angle B, let's relabel the picture. So tangent of B, here's B. Opposite now is 15. Adjacent is the 8 now. So opposite over adjacent is now 15 over 8. And now to find the angle measure for angle B, do an inverse tangent, 15 divided by 8, and this will approximately be 61.9. This is rounded to the tenths place. Again, you can go back and add 28.1 and 61.9. If they don't give you 90, you've done something wrong. Again, if you were running out of time, and let's say you still had to find B, and you didn't want to do the tangent ratio, remember you can also take this and just do 90 minus 28.1. It'll still give you that answer as long as you did the calculations correctly. So now I can fill in everything. So again, angle A, that was the pink, and that was 28.1. And then angle B, that was the 61.9. I've now completed the triangle by finding all three angle measures and all three side lengths. The next one wants me to find the value of x. Now, if you recall back in the 9-3 homework, those last couple problems were the reason why I gave that Algebra 1 review. Because we're setting up this information and x is going to be in our ratio now. So notice there's no letters on the angles. So what I'm going to do is I need to label my sides in relation to the acute angle that they've given me. So the x in relation to the 24 is the side opposite. The 20 in relation to this acute angle 24 is the adjacent side. Again, remember, here's your right angle. This side is the hypotenuse. I'm not looking for everything on this problem, only x. So now I'm going to do tangent of 24 is equal to opposite, which is x, over adjacent. And now I need to use my Algebra 1 skills. I need to multiply both sides by 20, which will cancel it out of the bottom. And now on your calculator, you can either choose to do 20 times the tangent of 24, or if you want to do tangent 24 times 20, do it in that order. You're still going to get the same answer either way, because remember, multiplication is commutative. So rounded to the tenths place, because that's what they set up here, is 8.9.
Wait, so we put tan or tangent times 24?
Well, you do tan, it should open the parentheses. Now, do not round that tangent of 24. Leave that huge number on your calculator and then multiply it by 20. And then hit enter. This little blob is supposed to be a multiplication sign. We're multiplying tan of 24 times 20. Yes. So now, let me change the question. I'm going to use the same numbers, but I'm going to move them. So the 24 is still here, but I'm going to put the x here and the 20 over here. So now, the 20 is now the opposite to the 24, and the x is now the adjacent. So now, tangent of 24 is equal to 20 over x. I need to get this variable out of the denominator. So I'm going to multiply both sides by x. That cancels it out of the bottom. And now I'm left with x times the tangent of 24 equals 20. Now to solve for x, I need to divide both sides by the tangent of 24. That cancels. And now on your calculator, you're doing 20 divided by the tangent of 24, and then you should be getting 44.9. And the variables in the bottom, you're using division to solve. When the variables in the numerator, you're using multiplication to solve. So, back in 9-2, we learned two special right triangles. I'm going to review them with you right now, because if you get a question like this that tells you specifically to use a special right triangle, and if you just do the tangent of 60 on your calculator, and you tell me that the answer is 1.732050808, you just got it wrong. So what we want it is in simplest radical form. So let me redraw the two special right triangles. 45, 45, and 90. And then 30, 60, and 90. For the quiz yesterday, you memorized that these two legs on the 45, 45 were A and A. The hypotenuse was A square root 2. Over here on the 30, 60, 90, the side across from 30 was A. Across from 60 was A root 3. And then across from the right angle is 2A. This is prior knowledge. This is 9-2. Now, for this lesson, we're getting rid of the A's. So what we're going to do is we're going to put a 1 in front of all these A's here. So now, instead, my triangles that I'm using are going to be these. When it's the 45, 45, 90, the numbers I'm using are 1, 1, square root 2. For the 30, 60, 90, it's going to be the 1, 2, 3 triangle. 1, 2, square root 3. Don't write the A's anymore. And now, when it wants me to find the tangent of the 60-degree angle, let me come here to my picture. Here's my 60. My side opposite 60 is square root 3. The side adjacent is the 1. So now I'm going to put the square root of 3 over 1. So the tangent of 60 is just the square root of 3. If you tell me it's that crazy long decimal, you get it wrong. Let's say it wants me to find the tangent of 45. I'm going to use this triangle. It doesn't matter which 45 I choose, because if I choose this one, the opposite is 1 and the adjacent is 1. So even if I change, I still get 1 over 1, and the tangent of 45 is 1. It doesn't matter which 45. And remember how we started class. I told everybody, test out your calculator, do the tangent of 45. Everybody should get 1. So that would be a nice fact to memorize. Now, let's say they said, let's do the tangent of 30. So let me quick redraw this triangle. 30, 60, 90, 1, 2, root 3. In relation to the 30 now, this is opposite, this is adjacent. So opposite over adjacent, 1 over the square root of 3. Can't leave that radical in the bottom. We need to rationalize. Multiply top and bottom by root 3. And the tangent of 30 is the square root of 3 over 3. So when it asks you to use special right triangles, this is how we have to solve the problem. Okay, the last one is the definition of angle of elevation. The angle that is the upward line of sight that it will make with a horizontal line. So for example, if you are standing right here and you look straight ahead, this is the horizontal line. And then if you were to look up at the sun, your other line of sight that you're making creates an angle of elevation. So a lot of times they're going to say from the ground up to what you're looking at, or sometimes it'll be from when you're standing. So let's try the last word problem. It says you are measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height, h, of the tree to the nearest foot. So I'm using my tangent ratio. So notice this is the angle of elevation here, the 59. The side opposite to the 59 is the h. The side adjacent to the 59 is the 45. So I'm going to be doing tangent of 59 is equal to h over 45. I'm going to solve for h by multiplying both sides by 45. It cancels. 45 times the tangent of 59 gives me 74.89 something. Rounded to the nearest foot, which means whole number, the height of the spruce tree is 75 feet tall. You will be getting lots of word problems with these trig ratios, and they will be involving angles of elevation and angles of depression.